In this video, we're going to solve 2007 AP Calculus Form B question number 4. So it says, let f be a function defined on the closed interval from between -5 and 5, with f of 1 equaling 3. The graph of f prime, the derivative of f, consists of two semicircles and two line segments as shown above. For -5, x is between -5 and 5, find all values of x at which f has a relative maximum. Justify your answer. So we would include the endpoints, but the fact that it says between that, we can't include it. So we have to look for where the slope equals 0 and also where it changes from positive to negative. And the graph of derivative is shown above. So if you look over here at f of -3, that would be one possible point. So f of -3. Another point would be f of 4. F of 1 is a minimum. And now for part A, you would say f prime of x equals 0 and f prime of x is greater than 0, then less than 0. F prime of x is less than 0. Therefore, a max. Okay, part B says, for all values of x between -5 and 5, find all values of x at which the graph of f has a point of inflection. Justify your answer. So now we have to look for the slope of this graph up here where it's going to equal 0, and it's also going to change direction. So if you look over here, the slope is 0 and it changes direction. Also over here, it's not defined, but it's still a point of inflection because it changes direction. So now you would say over here at x equals, what's the first one? -4, -1, and also 2. These are points of inflection because f double prime of x is greater than 0, then less than 0, or vice versa. Okay, part C says, find all values on which the graph of f is concave up and also has a positive slope. Okay, so that part's important, positive slope. So we're only looking for the parts above the x-axis, and it's also concave up. That means the slope of the slope is positive. So one potential area is -5 to 4. So we'd say between -5 to 4, -4, not 4. And what's the next one? We're only doing the positive. Otherwise, we would say -1 to 2. So we're only counting this part right here because that's above the x-axis. So you would say from 1 to 2, and you would say f prime of x is greater than 0, and also f double prime of x is greater than 0. Okay, part D says find the absolute minimum value of x on the closed interval over the closed interval from x is between -5 and 5. So now we can include endpoints. Explain your reasoning. Okay, so the first one that they gave us is f of 1. That's always a good one. So f of 1 is equal to 3. So now let's look at f of 5, because that's the endpoint. And also 4 wouldn't be it because 4 is a max. We already identified that. So f of 5 is going to be 3 plus the integral. Lower bound was 1. We're going to 5 f of x, f prime of x, dx. Okay, now I'm going to make this a little bit smaller so I have more writing room and move it over. Okay, so now, if I want to find the area, I got to find the area of this, which is positive because it's above the x-axis, and then I got to subtract out that little area right there. So now I would do 3 plus, the width of this is 3, 1, 2, 3, yep. So it's a triangle, 1/2, 3 times the height is 2, minus that little triangle, which is 1/2, 1 times 1. So now I'm going to get 3 plus 3 minus 1/2, which is equal to 5.5, 5.5. And I should write the equals over here and separate this so it's not confusing. Okay, the next part that I need to worry about is f of -3. No, not f of -3, f of -5. -3 would be a max. We already established that. So if I do f of -5, I'm sorry, it's all the way down here. That's going to equal 3 plus the integral from 1 to -5 f prime of x dx. Okay, now we have to fix these boundaries because the boundaries are all messed up. So I'm going to subtract it, put the -5 here, put the 1 here, put f prime of x dx, which is now going to equal, let me move this a little bit so I can still see. Okay, that's going to equal 3 minus the integral. I don't know how big I need. So I need to find this area over here. When I find this area, it's half of a circle. So, but it's also below the x-axis, so it's going to be negative. So now I'm going to put negative 1/2. The radius is 2 squared. Okay, and then I have to do the last part. So the last part is I got to find this area here. It's also a semicircle. So when I find that semicircle, I now need to say minus, what's the radius there? 1/2 pi, looks like it's 1 squared. So now doing the math, I'm going to get 3 plus, because negative times a negative is a positive, and now I'm going to get 4 2 pi minus pi over 2. So now if I think about this, 3 plus 2 pi, that's going to be 2 pi is 6 point something, 6 plus 3 is 9, 9 minus whatever that little piece is still greater than 3. So my absolute min is f of 1 equals 3. That's the absolute min. I hope this video helped.